All right, let's dive right in. We're surrounded by all this incredible technology, but what if I told you there's an invisible force that can obliterate it in an instant? No sound, no flash, just gone. We are talking about electrostatic discharge, or ESD, and trust me, it's a much bigger deal than you probably think. So let me just ask you this straight up. Do you think you can fry a super sensitive microchip without ever feeling that little zap of static electricity? The answer is a huge, resounding yes, and it happens all the time. See, the shock you can actually feel is thousands of volts, but the real damage can happen at levels so low our bodies would never ever notice. And get a load of this number, 35,000. That's the sheer scale of the power we're talking about. Just by walking across a carpet on a dry day, your body can build up a static charge of up to 35,000 volts. No, that is not a typo. You essentially become a walking, talking capacitor, just waiting for somewhere to discharge all that energy.
So the big question is, how on earth does this even happen? How do our bodies turn into these walking, high-voltage batteries? Well, it all comes down to some pretty basic physics. Let's break down how this incredible charge actually builds up in the first place. At its very core, static electricity isn't magic or anything. It's just a simple fact of nature. All it is an imbalance of electric charges sitting on the surface of a material. And the number one cause? Simple friction. That's it. Just two different materials touching and then separating.
This brings us to a really cool concept called the triboelectric series. Now, it sounds fancy, but just think of it as a ranked list. It shows which materials love to give up electrons and which ones love to grab them. So, when you rub two things together, like the soles of your shoes on a carpet, electrons literally jump from one to the other. And here's the key. The further apart those two materials are on the scale, the bigger the static charge you're going to generate.
And check this out. This shows just how much the environment around you matters. On a really dry day, let's say 20% humidity, that simple walk across the carpet can get you all the way up to that shocking 35,000 volt figure. But on a humid day, maybe 80% humidity, the moisture in the air actually helps dissipate that charge, and you might only build up 1,500 volts. So humidity is basically your secret shield against ESD. Dry environments, they're the real danger zones.
Okay, so we've established that the human body can be a serious static electricity powerhouse. Now let's look at why that is so utterly catastrophic for the delicate electronics we all rely on every single day.
This quote, it's from a US military standards for handling electronics, and it says it all. It puts sensitive parts into classes, and class I is the most vulnerable category. We're talking sensitive to between just 100 and 1,000 volts. So basically, the vast majority of computer chips and components are in the highest possible risk group.
Just look at these numbers. An EEPROM chip, that's a type of memory you'd find in, say, old video game cartridges. It can be permanently destroyed by as little as 100 volts. A CMOS chip, which is fundamental to the processors in your phone and computer, can fail at just 250 volts. So that 35,000 volts we generated, it's like using a sledgehammer to crack an egg. It's total overkill.
This is the data right from the source materials. It just perfectly highlights the massive mismatch here. The power that we can carry around in our bodies is just orders of magnitude greater than what these tiny, incredibly intricate components can handle. It really is an invisible, silent, and terrifyingly effective killer of electronics.
All right, the threat is clear. It's pretty scary, but it's not hopeless. We can't stop static electricity from existing. It's just a part of our world. But what we can do is build a kind of fortress against it. Let's explore how to create a totally static safe environment.
This right here is the single most important rule of ESD protection. You will never, ever eliminate static electricity. The goal isn't to fight nature, it's to manage it. We need to control that charge and give it a safe path to travel, a path where it can't do any harm.
So how do we control it? Simple, by creating a grounded environment. This slide is basically your checklist. Everyone and everything, from the person working to the floor to the table, is all connected to a single common ground point. This creates a path of least resistance so any static charge can just drain away safely. And you'll notice it's also super important to get insulators. Things like plastic, styrofoam, even wood out of the area because those things just love to hold a charge. The principle really is that simple. When everything is connected to the same ground, you create one continuous safe path for electricity to flow. It's a complete system, and it's all designed to keep everything at the exact same electrical potential. That way, there's no reason for a sudden destructive spark to ever happen. Now, creating a full static safe workstation like that is obviously the gold standard.
But what can you do personally to protect the components that you handle? Let's talk about the essential tools and the procedures you need to know.
Look, if you remember absolutely nothing else from this, please remember the wrist strap. This simple, cheap device connects you directly to ground, and it is constantly and safely draining away any charge your body happens to accumulate. It is your personal #1 first line of defense against ESD. And of course, using it correctly is key. So here is the procedure. First, you put on the wrist strap, and you make sure it's properly connected to ground. This makes sure your body is neutralized. Then, and only after you are safely grounded, should you even think about opening the protective bag that the sensitive component is in. This sequence is absolutely positively critical.
So, we've seen the incredible voltage our own bodies can generate, and the tiny amount it takes to destroy the technology we depend on every day. The threat is real, but you know what? So are the solutions. The power to protect your electronics is literally in your hands. So the only question left is, what will you protect?